Yeah. Now let's look at if we have a scale data in place, what all we can do on that data, or what all we should do on that data. So for that, I would like to look at the same example I'll use, but from these 5 fields. I'll look at these 5 fields. The last month bill that is spent by the customer on these 5 different calls: long distance calls, last month bill; toll free, the last month bill; equipment rental, last month bill; calling card, and wireless. These are the 5 services which the telecom company is offering, and whatever was the bill which was paid or which was generated for this 1,000 customers in the last month, I wanted to do some kind of analysis on that. So before taking them together, I have to look at them individually. So that's where I am taking these 5 variables into consideration to do some kind of analysis on these 5 variables, right? Now, what analysis I can do as part as, so these are all scale variables because they can accept any number. Some numbers countable or calculatable kind of stuff, they are not quantified kind of numbers. The bill amounts. So these kind of data I am treating it as a scale data, and on this scale data I can do the same thing, frequencies, but along with that, on these I can do that average, all the kinds of analysis can be done on this kind of a data. So for that purpose, we go with, in the frequencies part, so whatever can be analyzed on the scale data, the heading is frequencies itself, but lot of statistics can be computed, descriptive statistics, which are mean, median, mode, standard deviation. Lot of things can be calculated on this data. So I can go to that either from this frequencies tab of the analyze, or the same thing can be obtained from descriptives. There is one more under that analyze drop down itself, descriptive stats. There is a frequencies which was the first one, and we'll use that itself, but descriptives is a slightly condensed version of that. So one of these two we can use to generate a full-fledged analysis of a scale data. Full-fledged analysis of a scale data can be obtained through one of those two, again taking one variable at a time, right? All right, so let's go with the frequencies part, right? I'll show you what all you can do in case you come across any scale data. I'm taking these out. I'll pull back these 5 scale data. Long distance last month, toll free last month, equipment rental last month, calling card last month, wireless last month. These are the 5 bills of all the 1,000 customers. I'm taking these 5 charts. The most common chart for a scale data, for a nominal data, we said we can go either for a bar chart or a pie chart. But when it comes to a scale data, the most common chart is a histogram. The way the histogram plots is, it takes all the values on your x-axis and the frequency at which they are occurring on the y-axis, and it plots a kind of a smooth line, or it could be in terms of small columns together. So the x-axis is a continuous stream of values, not the order in which the data is available. Like in our nominal data case, the x-axis was, even if it has been a bar graph or something, the x-axis would be like did not attend high school. These are the values on the x-axis. They are not numbers. Whereas when it comes to histogram, you will find something like, okay, 20, 30, 40 kind of numbers on the x-axis, and the values would be joining. The frequency would be joined as simple dots and all the points joining that dots, or it could be small rectangles. We'll see that. And the most important thing for any analysis that is done with respect to the scale data is check for the normality of the data. Now, what does that mean is, if I plot a histogram, in general, if I have to use that data either for prediction purpose or for conclusion purpose, my data should be pretty much normal in nature. It should not be abnormal. What do we mean by that? Normal data, generally people have observed, again pattern wise, a normal data, when I try to plot a histogram for that, it looks more or less like a simple bell curve. If it is a normal data, the data for which I am plotting the histogram, it should look more like a bell curve. Again, what are the features of this bell curve? One, it is looking symmetric. Two, aptly height, not too much high or not too much flat. There is an aptness in the height. So whatever is on the left hand side, more or less similar on the right hand side. That kind of data is what we call as normal data. And if we have to do some kind of predictions or forecastings, like using regressions or time series analysis, any of the analysis, the first preliminary condition for us is the data should be normal in nature, because most of the statistical tests in the world today, they were designed under the assumption that the data is normal. If the data is not normal, right, probably the data on which we will look at now may not be normal at all, which means when I plot the graph, it may not look something like this, right? And there are some other measures for, without a graph also, just by looking at some values, I can say whether it is normal or not. Let's say if it is not normal, then there are two things that we need to do as analysts. One, either I should transform the data, which we will do for some of our data. Either I should transform the data, which means do some other equation on that data. Instead of leaving the data as it is, probably take logarithm of all the data, some kind of transformation, do a square root of the data. So which means the data is not normal in its original form, but after transformation, probably it may become normal. But my intention is I have to make it normal. Only then, whatever I am doing, let's say the comparisons or predictions, they will have a real meaning, right? For that reason, I have to make the data as much normal as possible. So either I should do a transformation or eliminate outliers. Extreme values could be there in my data. So these could be and or. I can do both the things also, or I can do one. But at the end, I have to make sure after doing all this, somewhere my data is coming into its normal form. Only if it comes into this normal form, only then I can very well use it for other purposes. Right? Only then I can use it as a part of my correlations, regressions, any kind of statistical tests. For that reason, we have to first check for the normality, and that can be done through my histogram as well as the normality plot. So the normality plot is, it shows, so what should be the values in case it is normal, and my histogram will show me what is my actual plot. If the actual plot is very much closer to this bell curve, then I say more or less it is normal. I can very well go. See, exact normality we cannot get. We are working on that data. We are not working on